Good day, everyone, and welcome to this class. However, although the class was made for my students who are preparing for exams in physics. So, however, if you came here by chance, you are welcome. The topic will be covering using a set of questions are electromagnetic waves. Also talk a little about gravitational field and then some aspect of electricity. Okay, the first question is on Newton's law of universal gravitation and then all other related concepts. It says Newton's law of universal gravitation states that every object attracts every other object with a force that is directly proportional to the product of mass and inversely proportional to the square of distance. I says provide a formula to illustrate this law. I think I is the only question that is associated with the law directly. All others are derivatives. So this is the formula. The force is equal to gm1 m2 over r square. F is the force, g is gravitational constant, m is the mass of object 1, and then m2 is the mass of object 2. R is the distance between the centers of the masses. So this is how we can illustrate the law diagrammatically. Mass 1, mass 2 is attract each other by a force F. In this case, F1 is equal to F2. So the force that M2 attracts M1 with is the same force that M1 attracts M2 with. Okay, what is escape velocity? And then if the mass of the earth is me, derive an expression for force per unit mass and escape velocity. As the name implies, escape velocity is the minimum speed or velocity that an object needs to leave the gravitational pull of a planet or another astronomical body, another celestial body. It depends on the mass and radius of the body, and then the distance of the object from the center of the celestial body. So how do we derive an expression for escape velocity? Kinetic energy that everybody needs to escape the gravitational pull of another body is equal to half mve square, where v is the escape velocity. So if the body has the escape velocity and then you apply this formula, it will be leaving the astronomical body with that particular energy. And then we know that it's also equal to the work done on the object as it leaves the astronomical body. And work done is the product of force, times the distance. So that's why we have F times R here. But that force is equal to gravitational force, which is, if it is on Earth, is gmem over r square. So me is the mass of the Earth, and m is the mass of the body. So once we cancel out and make ve subject of the formula, or ve square subject of the formula, we're going to be having something like this. So you take the square root of both sides and you have the first formula for escape velocity. ve is equal to square root of 2 gme over r. When you know the square root of the mass of the earth or mass of the astronomical body, this is the formula to apply. However, from previous work, we know that mass of the earth is given by gr square over g. That means that when we substitute this in place of me here, this is what we'll have as the escape velocity. G here is acceleration due to gravity, and capital letter R here is radius of the earth. Sorry, let's go back. So, and then force per unit mass is same thing as dividing the force by the mass, F over m. So if we have F as being equal to G m1 m2 over r square, once we divide both sides by m, any of the m, if m that we're talking about is equal to m1, and then me is equal to m2, we would have it that F over m is equal to gme over r square, because when you divide m1 here by m1, they will cancel out, and then you'll be having this alone left in the equation. So force per unit mass is given by gme over r square if we are talking about the earth. The other question says calculate the gravitational force of attraction between two planets of mass this and this, separated by a distance of this. And then the gravitational constant has also been given. So if I were to solve this question, so apply the formula from Newton's law of universal gravitation, and then according to this formula, the force that exists between two masses, F, is given by gm1 m2 over r square. So which is equal to, the gravitational constant is this, we'll substitute it for g here, we'll have this, and then m1 is the first mass, any of them can be the first mass, 10 raised to the power 24, that's why we'll have 10 raised to the power 24 here, and then m2 is the second mass, which is 10 raised to the power 27, that's why we'll have 10 raised to the power 27 here, all over r square. R is the distance between them. So in our question, the distance between them is 10 raised to the power 20 meter. This is 10 raised to the power 20 meter, and then remember it is squared. So that's why we'll have the square here. So once you multiply that with a calculator or with arithmetic knowledge, this is what you have. And then once you solve, you get that the force between these two planets is 6.67 Newton. And then the second question says, if the radius of the earth is this and acceleration due to gravity is this, calculate the escape velocity of a rocket from the earth's gravitational field. So remember, escape velocity is given by the square root of 2gr, and then especially in this particular case when we're given the radius of the earth and g, so it means that this is the formula to apply. So substituting to the formula, this is g 9.8, and then this is r. Once you multiply them out and take the square root, you have that the escape velocity is 11,200 meter per second. Okay, the next question says, what are primary and secondary cells? Give examples. State and explain 3 defects of primary cells. A battery of EMF 20 volt and internal resistance of 5 ohms is connected to a resistor of 35 ohms. Find the terminal potential difference. So a formula was given. So what are primary cells? Primary cells are those cells that cannot be recharged once they are exhausted. Why? Because the chemical reactions within these cells cannot be reversed by applying electric current in opposite direction. So the chemical reactions are irreversible. So once it is exhausted, it is exhausted. Examples of primary cells include alkaline batteries, and then the dry cells we use all the time. Secondary cells are rechargeable, as cells that are rechargeable. Why? Because the chemical reactions that produce the electricity are reversible. So all that is needed is to connect electricity, direct current, in opposite direction to the current it supplies, and then that would charge the battery, and then it becomes recharged. It can be used over and over again. Example are the popular lithium-ion battery that is used in mobile phones and then electric vehicles. and then nickel cadmium batteries. So what are the defects of primary cells? Polarization. Polarization has to do with the production and accumulation of hydrogen bubbles around the positive electrode. It covers the electrode and then prevents it from delivering current. So this reduces capacity because the cell will need to overcome polarization. We need to overcome the effect of the hydrogen bubble accumulation. Another defect that we see in primary cells is local action. When the zinc plate that is used for the negative electrode is not pure enough, or due to usage, it begins to wear away. A local action, a defect known as local action, result. What happens is that the cell will not be able to deliver current as it's supposed to because of this defect. Another thing that can occur in dry cells, I don't know whether you have noticed it in primary cells, is when the electrolyte leaks out. Sometimes you see some stains on the body of the cell. Is due to leakage. It can stop the cell from functioning. In fact, when the dry cell experience leakage, most times it doesn't work any longer. Okay, a battery of EMF 20 volts and internal resistance of 5 ohms is connected to a resistor of 35 ohms. Find the terminal potential difference. First, what is terminal potential difference? Terminal potential difference is the potential difference when a cell is delivering electricity in a circuit. You see, cells has components within them that offer some resistance to the flow of electricity. So certain of the electromotive force that drives current in the circuit is used to overcome this resistance within the cell, so that at the end of the day, the potential difference or electromotive force that is available to drive electricity around the circuit is lesser than the electromotive force of the cell or battery. So the resistance within the component of the cell is called internal resistance. It's denoted by a small r here. It's called internal resistance. And then this is the potential difference that drives electricity around the circuit. So when you add that potential difference with the potential difference that is required to overcome the resistance within the cell or battery, you get the electromotive force E of the battery. So according to Ohm's law, potential difference is equal to current times resistance. But in this particular case, the potential difference is the electromotive force of the cell, and then the resistance is both the internal resistance and the external resistance, because we do not know the current and we are told to find V, which is the potential difference when the cell is delivering current to an external circuit. So when we substitute, we have that I is 0.5 ampere. So the current that the cell delivers is 0.5 ampere. Some of this current passes through the internal circuit, and some pass through the external. Some of this current passes through the internal of the battery, and some pass through the external circuit. So since R, the external resistance, is 35 ohms, and then we know that from Ohm's law, V is equal to IR, and V happens to be this potential difference. That's the terminal potential difference. So at the end of the day, when you substitute, you get that the terminal PD is 17.5 volts. So this is question 3. The first question says distinguish between mechanical and electromagnetic waves. And then the next question says arrange the following electromagnetic radiation in order of increasing wavelength: ultraviolet, gamma rays, radio waves, infrared, visible light, and X-rays. And then electromagnetic waves from the sun reach the earth even though the space between is a vacuum. Sound waves emitted by the sun cannot reach the earth. Why this different? It is good to know that the reactions that produces heat and light from the sun also produces sound. However, we don't hear any sound. Why? That's what this question is asking. So why mechanical waves are actually are waves that require medium to travel, such as sound waves and then water waves. Without this medium, these waves cannot travel. Why? Because it is the particles of the medium that vibrate and transmit these waves, that transmit the disturbance or energy, as the case may be. And then electromagnetic waves are waves that do not require a medium to travel, such as light waves or radio waves. They are caused by oscillation as vibration of electric and magnetic fields within the wave. So they do not need a medium. Light can travel with or without a medium. So when you arrange the electromagnetic waves provided in the question in order of increasing wavelength, this is what you will have. Gamma rays has the shortest wavelength, followed by X-rays, and then ultraviolet waves, visible light, infrared, and radio waves. So it is important to note that the shorter the wavelength, the higher the penetrating power of the electromagnetic waves. And also as wavelength increases, frequency reduces. That's another thing you should in case you are asked to arrange in order of increasing frequency. So you know that frequency is reducing as the wavelength is increasing. So if you are asked to arrange in order of increasing frequency, radio waves will be the first. So it will be in the reversed order. So it will be in this order. So this order going backwards is increasing frequency, and then this order going forward is increasing wavelength. Electromagnetic waves from the sun cannot reach the earth because electromagnetic waves from the sun reach the earth because they can travel in a vacuum, and then the space between the earth and the sun is a vacuum. Electromagnetic waves do not require a medium to travel, whereas sound waves emitted by the sun cannot reach the earth because they are mechanical waves. They require a medium to travel, air and water, and then there is no such medium between the earth and the sun. Thank you.